Let's begin with the definition of HSM. Carl Salomon assumes that at a certain cutting speed, which is between 5 to 10 times higher than in conventional machining, the chip removal temperature at the cutting edge will start to decrease, like you see in this picture. Also, this picture shows the high-speed cutting ranges in machining of various materials, which with the yellow color show the transition range, and the black color show the high-speed machining range. So, let's see what are the advantages of high-speed machining. He have a high material removal rate. He have a high surface finish. He increased productivity. He has the possibility of machining of very thin walls. He has the reduction in lead times. He has low cutting force. He has cutting tool and workpiece temperature are kept low. The connection time between the cutting edge and workpiece is short, and it eliminates the need of coolant. And finally, he has a reduction of producing process. For example, when we see here the features and the effect, when we have reduced heat transfer into the workpiece, we have part accuracy. When we have a reduction of cutting forces, we have part accuracy and surface quality. When we speak about increased cutting speed, we speak about stability. The effect is the stability of a rotating cutting tool feed rate and the increased material removal. Seeing now the application areas. Industry which deals with the machining of aluminium to produce automotive components, small computer parts, or medical devices. Aircraft industry involves machining of aluminium, often with thin walls. The mold industry which requires dealing with finishing of hard materials. Let's see now the demands on the machine. The spindle range is less than 40,000 rpm. The spindle power is more than 2000 kilowatt. The programming feed rate is between 40 and 60 meters in the minute. The rapid travels is less than 90. The block processing speed is between 1 and 20. The high thermal stability and rigidity in spindle. The air blast or coolant throughout the spindle, and the advanced look ahead function in the CNC. This picture shows an example of high-speed machine. This is an horizontal center of HSM. This picture also shows a high-speed machining center. It's a vertical center of HSM. Passing now to other themes, switching the cutting tools. The high-speed machining or HSM has his or their tools. We have the the TN and TCN coated carbide for material with hardness less than 42 HRC. We have also the TLN coated carbide for materials with hardness 42 HRC and above. For special applications like hard turning, we have HRC between 60 and 65. PCBN is used. Cubic boron nitrate (CBN) and ceramic for cast iron. Polycrystalline diamonds (PCD) and ceramides are used for aluminium. Let's see what are the recommended parameters. The first recommended parameter is the true cutting speed, as the speed is dependent on both spindle speed and diameter of tool. HSM should be defined as true cutting speed above a certain level. The second recommended parameter is material removal rate. Material removal rate is given by this formula. AP and AE and VF are like this. The AP is the vertical distance from tool tip to the reference point and is measured by the millimeter. AE is the step over distance, it's measured by millimeter, and the VF is the feed speed and is measured by millimeter per minute. The third recommended parameter is the surface finish. The surface finish is depends upon cutting tool geometry, coating of the cutting tool, wear status of the cutting tool, etc. Seeing now some comparisons. When we want to compare the conventional machine with high-speed machine, for example, in conventional machine, we have the maximum speed is 600 meter per minute, but in HSM we have speed starts at 600. The max speed in conventional machine is 40. The feed starts at 100 in high-speed machines. In the conventional machine, we have require high levels coolant, but in the high-speed machine with coolant, feed rate can go more than 2000 and no need for coolant for low feed rate. Let's see again something we can also compare in conventional and HSM. In conventional, the contact time between tool and work is large, but in HSM, we have contact time is short. In conventional machine, we have less accurate workpiece. In HSM, we have more accurate workpiece. In conventional machines, we have cutting force is large. In HSM, we have cutting force is low. We have low surface finish in conventional, but we have high surface finish in HSM. We have material removal rate is low in conventional, but we have material removal rate is high. We have cutting fluid is required in conventional, but we have cutting fluid is not required in HSM. Now passing to other comparison, which is the comparison between HSM and the EDM. In HSM we have material removal rate high, but in EDM we have material removal rate is low. In HSM we have dimensional tolerance between 0.02 mm, but in EDM dimensional tolerance is between 0.1 to 0.2 mm. In HSM we have no feed of making cutting tool according to the counter to be machined. In the EDM, cutting tool has to be made according to the contour to be machined. Now, seeing the disadvantages of high-speed machining. Need for expensive and special machine tools with advanced spindle and controls. We have excessive tool wear. We have good work and process planning necessary, and it can be difficult to find and require advanced staff. Seeing now conclusions. HSM is not simple high cutting speed. It should be regarded as a process where the operations are performed with very specific methods and precision equipment. HSM is not necessarily high-speed spindle machining. Many HSM applications are performed with moderate spindle speeds and large-sized cutters. HSM is performed in finishing in hardened steel with high speeds and high feeds, often with 4 to 6 times conventional cutting. HSM is high productive machining in small-sized components, in roughing to finishing, and in finishing to super finishing in components of all sizes. Even throughout HSM is known for a long time, the research are still being developed for further improvement of quality and optimization of cost. Thank you everybody for watching the video. I hope that you like it. Don't forget to put like if you like this video and to subscribe to the channel. Thank you very much and goodbye.